Hello everyone. In this particular video, we are going to solve problem number 1.5 from Irodov, and that is related to kinematics. So first let us read out the problem and then we'll solve the problem step by step. So there are two particles 1 and 2 that are moving with constant velocities v1 and v2 respectively, and at the initial moment their radius vectors are equal to r1 and r2. So it is asking that how much these four vectors be interrelated for the particles to collide. Okay, so let us first draw those two particles and their position vectors. So this is particle 1 and let us say this is particle 2, and this is the origin we are having. This is the x direction, then this is y direction, and this is the position vector r1 for particle 1, and this is the position vector for particle 2. Okay, and it is having some velocities v1 and it is having the velocity vector of v2. Okay, and both are constant. So the particle to collide, what should be the condition? For example, if we make this particle in the rest condition, then in that particular case, with respect to this particular particle, it will have the relative velocity of 1 with respect to 2, and that relative velocity should be in this particular direction in order to collide happen. Okay, so this is our basic logic in order to solve the problem. Okay, so let us first write the velocity vector of 1 with respect to 2 is equal to velocity of 1 minus velocity of 2. Okay, so this is the velocity of 1 with respect to 2. So when we make the particle 1 at rest, then this is the velocity at which the particle 1 will move. Now this velocity should be in this particular direction. Then how do we find this direction? So from the triangle law, we know that, for example, if we have the two vectors, let us say this is a vector, this is b vector, then this is c vector, then we know that a vector plus b vector is equal to c vector. Similarly, in this case, let us say this is x vector, we can write r1 vector plus x vector is equal to r2 vector. So x vector we can write r2 vector minus r1 vector. In order to equate the position vector of 2 with respect to 1, so this is basically r21 is equal to r2 vector minus r1 vector, position vector of 2 with respect to 1, and this is the velocity of 1 with respect to 2, and this both should be equated if we are having the unit vector. So let us first find out the unit vectors. So for relative position, we are having the r12 cap, this is r21 cap is equal to r21 vector divided by r21 magnitude. So this will equal to r2 vector minus r1 vector divided by r2 vector minus r1 vector absolute value. Then second thing is relative velocity unit vector. So that is what v12 is equal to v12 vector divided by v12 vector magnitude. So that will equal to v1 vector minus v2 vector divided by v1 vector minus v2 vector magnitude. Now we can equate these two particular vectors in order to collide happen. So r2 vector minus r1 vector whole divided by r2 vector minus r1 vector magnitude is equal to v1 vector minus v2 vector divided by v1 vector minus v2 vector, or we can also write r1 vector minus r2 vector divided by r1 vector minus r2 vector is equal to v2 vector minus v1 vector divided by v2 vector minus v1 vector. So this particular case is the one when the particle 1 is at rest and the particle 2 is actually moving in this particular direction. So this is the condition for the collision to occur. Thank you.